Are you curious about how to implement network load balancing in Windows Server? Look no further. In this video, I will walk you through the steps of setting up and managing an NLB cluster using two NLB nodes. We will cover everything from configuring port rules to selecting the right client affinity options. Whether you are a Windows Server Pro or just starting out, the video has everything you need to know to get started. So let's dive in and explore the world of network load balancing in Windows Server. Hey, this is Kiran, and in this video tutorial, we will talk about everything related to network load balancing in Windows Server. I work as a tech lead in one of the IT companies in India, and I've been working with Windows Server for a very long time. This video course would be useful for someone who would like to implement network load balancing in their environment, or just wants to learn network load balancing in Windows servers. By the way, regardless of which version of the Windows Server operating system you use, the concept that I'll talk about and the demos I'll show you here apply to almost all Windows Server operating system versions. Here are the topics which I'm going to cover. I will start with an overview of network load balancing (NLB). Before creating an NLB cluster, we'll look at the prerequisites you need to create an NLB cluster. I will talk a bit about some of the decisions that you're going to have to make in terms of how you actually want to go about load balancing those user requests. And here in just a minute, when we talk about the cluster operation mode, that is one of the big decisions that you'll have to make in terms of how you actually want NLB to function. We'll talk about some of the pros and cons associated with different decisions you'll have to make on configuring NLB. I will also show you my lab setup for the demos. This video demonstrates the end-to-end installation of Windows Network Load Balancing on two different hosts, NLB01 and NLB02. To set up an NLB cluster, you just need to install NLB and the service or services you want to use on the servers in your cluster. In my case, I will also be running a web server on my NLB nodes. Our first task is to install the NLB feature. I will show you the process of installing the NLB feature and the IIS web services role onto our machines, NLB01 and NLB02. We'll discuss the initial installation and post-installation configuration of NLB nodes. Additionally, I will show you how to customize the default IIS page on the cluster nodes to display the hostname of the NLB nodes. This will be useful during the testing of the NLB cluster. I will then show you how to create an NLB cluster. This process involves pulling a group of servers together into an NLB cluster, which is remarkably simple. There are just a couple of clicks that you need to know. When creating an NLB cluster, you must define port rules and client affinity settings. I will explain the available options for client affinity settings. These settings allow you to add a type of stickiness for users accessing these services being load balanced. If you need users to go to a specific server every time they connect, you can use the affinity based on the subnet they are coming from or the user's IP address. I will also test the NLB cluster. I will show you how to manage an NLB cluster, specifically how to stop, start, suspend, resume, and drain stop services on the NLB nodes. Finally, we'll cover upgrading our NLB cluster. Let me provide an overview of NLB, Network Load Balancer. Windows Network Load Balancing (NLB) is a really useful feature that distributes network traffic among multiple servers. This helps prevent any host in the NLB cluster from becoming overloaded and improves overall performance. It's great because it works for load balancing anything as long as you know which port needs to be passed and separated across all the machines in the cluster. NLB transparently partitions the client requests among the hosts and let the client access the cluster using one or more virtual IP addresses. The virtual IP, VIP, would typically be a DNS entry stored in your DNS server. This is really cool because from the client's point of view, the cluster appears to be a single server that answers the client requests. If the traffic increases, administrators can simply plug another server into the cluster, and if traffic decreases, servers can be taken offline and the NLB cluster will balance traffic among the remaining hosts. NLB is commonly used for stateless services like IIS and web services. It's a great way to balance network traffic across multiple servers with data being stored on servers like database servers that users access. NLB has been used in the past for other technologies such as remote desktop services, VPNs, and even threat management gateway solutions. Although the NLB console in Windows operating systems hasn't changed much over the different versions, it still gets the job done and is a really useful load balancing tool in Windows servers. Before installing the NLB feature, it is essential to consider the network prerequisites, specifically the networking protocol to be used for load balancing requests across the servers participating in the NLB cluster. To successfully install NLB, the NLB feature needs to be enabled on every server that will be part of the NLB cluster. NLB provides three options for the network protocol to use: Unicast, Multicast, and IGMP Multicast. Each of these protocols has its advantages and disadvantages. Please take the time to consider them before choosing the one that suits your needs. But I'll show you the demos using the Unicast protocol because I cannot use Multicast or IGMP Multicast in my virtual environment. However, despite the protocol used, the result is the same. When choosing a protocol, it is important to consider the pros and cons of each of them. Let's understand the pros and cons of using Unicast. Unicast is a one-to-one communication between two different machines. It typically works well and doesn't require special network configuration. If configuring other protocols such as Multicast or IGMP Multicast is challenging, consider using Unicast as a reliable alternative. But to use Unicast, a second NIC is required on each NLB host. One downside of using Unicast is that it requires communication across all machines in the cluster. This is done by flooding the subnet, sending traffic to all hosts and every other machine on the subnet. Subnet flooding can have a negative impact on your network. Although Unicast is easy to set up, the more traffic that enters that subnet, the more it will be visible and will have to be dropped by all other machines on that subnet as well. While Unicast is a reliable alternative to other protocols when configuring NLB clusters, it is not a viable option in most production scenarios due to its inherent limitations. In such cases, consider using Multicast or IGMP Multicast. The next protocol is Multicast. Multicast simplifies the setup by eliminating the need for a second network card on NLB hosts. However, it doesn't solve the problem of network flaring. Moreover, it requires special network configurations on physical networking gear, which should support multicast for it to work. Also, additional routing entries are required to support it. The third protocol is the IGMP multicast. In most production environments, it is considered a best practice to use IGMP multicast when using an NLB cluster. So IGMP stands for Internet Group Management Protocol. This is because IGMP multicast utilizes additional technologies that prevent subnet flooding and do not require a second NIC on your NLB hosts. However, to use IGMP multicast effectively, you must configure your network gear to support it and make additional configurations. Most organizations have networking equipment that can handle IGMP multicast. However, in smaller environments with less advanced networking equipment, this may be a question mark. In summary, please consider the advantages and disadvantages of each protocol option when configuring NLB clusters. While each has its benefits, there are also potential downsides to consider. To set up a two-node NLB cluster in Unicast mode, I will run the virtual machines for this demo on my standalone ESXi host. These are the virtual machines that I've already set up. Each virtual machine will have the following specifications. For operating system, I'm going to use Windows Server 2022 on all these virtual machines. And again, all these virtual machines have 2 vCPU, 4 gig of RAM, 60 gig of HDD, and these virtual disks are thin provisioned. I've already configured the domain controller and the DNS server role on the virtual machine DC01. The AD domain name is tastybiryani.local, and my two NLB nodes, NLB01 and NLB02, are already joined to the AD domain tastybiryani.local. On my two NLB nodes, I'm going to install NLB feature and IIS role. As mentioned before, if you're using Unicast mode for your NLB cluster, you need to have two network adapters for each NLB node. Okay, you can see I have NIC1 and NIC2 on my NLB hosts. This is because in Unicast mode, all the nodes in NLB cluster share the same MAC address. This means that all traffic sent to the virtual IP address of the cluster will be forwarded to all nodes in the cluster. This can result in a significant network traffic, particularly if your NLB cluster is large. To reduce network traffic, NLB nodes in Unicast mode typically uses two network adapters, NIC1 and NIC2. One network adapter is used for cluster traffic, while the other network adapter is used for management and internode communication. In my case, I will use NIC1 for cluster traffic and NIC2 used for management and internode network communication. The network adapter used for cluster traffic, that is NIC1, is assigned a virtual MAC address. In Unicast mode, each virtual machine in the NLB cluster will have the same MAC address assigned to its network adapter used for cluster traffic. This network adapter is connected to the same network as the clients that will access the NLB cluster. In my case, the adapter is connected to my production network, which is 192.168.10.0/24. So when a client sends a packet to the virtual IP address of the cluster, the packet is flooded to all the nodes in the cluster of NIC1, whereas NIC2 is used for management and internode communication, and NIC2 is not assigned the virtual MAC address. The adapter NIC2 is typically connected to a different network than the clients. I have connected this to my heartbeat network 192.168.50.0/24. This allows the nodes in the cluster to communicate with each other and with the NLB management console without flooding the network. I will not specify the default gateway for NIC2, which is used for management and internode communication, because the Windows operating system doesn't recommend having two default gateways. So as discussed, if you create the NLB cluster in Unicast mode, all VMs in the cluster will have the same MAC address assigned to its network adapter used for cluster traffic, which in my case is NIC1. This requires that all the network traffic on the switches be port flooded to all the NLB nodes. In switched networks, port flooding is usually prevented by switches learning the MAC addresses of hosts that send network traffic. However, when using a Microsoft NLB cluster, the cluster's MAC address is hidden for all outgoing traffic to prevent the switch from learning it. This can cause network issues, so you need to configure the virtual switches to prevent this. Since I'm using an ESXi host, I must allow MAC address changes and forged transmits on the port group to which the network adapters for cluster traffic of NLB nodes are connected. In my case, NIC1 is used for cluster traffic of NLB nodes and is connected to the production port group. And the security settings for the production port group show that allow forged transmits and allow MAC changes are set to inherit from vSwitch, where these settings are allowed in my case. On a Hyper-V, you have similar options available that you can enable on the virtual switch. All right, enough of PowerPoint. The first demo is to install NLB feature and IIS role. So after verifying the prerequisites for NLB and showing you the lab environment to be used for creating an NLB cluster, let's move on to installing the NLB feature on the NLB nodes NLB01 and NLB02. So you must deploy the NLB feature on all servers that will participate in the cluster. I will set up a 2-node NLB cluster in Unicast mode. And before installing the feature, it is important to consider the network prerequisites, particularly the networking protocol to be used for load balancing requests across the servers participating in the NLB cluster. This topic was already discussed in the previous slides. All right, I have already logged into NLB01 using an administrator account. So I'm going to open up Server Manager, click on Manage, and click on Add Roles and Features. Click Next on the Before You Begin page. On the Select Installation Type page, keep Role-Based or Feature-Based Installation selected and click Next. On the Select Destination Server page, select the option Select a Server from the Server Pool. Choose NLB01 Server and then click Next. On the Select Server Roles page, select the Web Server IIS Server Role. And if it prompts you to install the management tools, simply click on Add Features and then click Next. On the Select Features page, scroll down a little and choose Network Load Balancing. And if it prompts you to install the management tools, simply click on Add Features, click Next. Simply click Next on the Web Server Role IIS screen. Keep the default selection on the Select Role Services page and then click Next. On the Confirm Installation Selections page, you can choose to select the option Restart the destination server automatically if required. However, this option is not necessary as the role and feature that we have selected do not require a restart of the computer. You can review the selected roles and feature. Click Install to begin the installation. Alright, I'm going to wait for the installation to complete. Okay, you can see the installation has successfully completed. Click on Close. I will perform the same steps to install the NLB feature and IIS role on NLB 02 as well. So I've already logged into NLB 02 as an administrator. I'm going to open up Server Manager. Click on Manage, click Add Roles and Features, click Next. Select role-based or feature-based installation, click Next. Keep the option Select a server from the server pool selected, and then ensure NLB 02 is selected. Click Next. On the page, select Server Roles, select Web Server IIS, and if it prompts you to install the management tools, click on Add Features. Click Next. On the Select Features page, scroll down a little and select Network Load Balancing. And again, if it prompts you to install the management tools for network load balancing feature, click on Add Feature, click Next. Simply click Next on the Web Server Role IIS page. Keep the default selection in the page Select Role Services and click Next. Again, you don't have to check this option to restart the server automatically because the role and feature that we have selected doesn't require a reboot. I'm going to click on Install, wait for the installation to complete. Okay, you can see the installation has succeeded on NLB 02 as well. So now we have successfully installed the NLB feature on both the NLB nodes. I'm going to click on Close. Okay, so for now we have installed the NLB feature and the IIS role on both the NLB nodes. Now before creating the NLB cluster, I'm going to customize the default IIS page to display the host name of the NLB nodes, which are also our web servers. So back in NLB 01, I'm going to open up Microsoft Edge. And if I type http://localhost, you can see the default IIS page on this server. So I'm going to customize this page to show the host name of the server. All right, I will go back to Server Manager, click on Tools, and click on Internet Information Services IIS Manager. I'm going to maximize this. I will expand the node name NLB 01 and expand sites. I will right click on default website and click on explore. And now I'm going to right click on iisstart.html file and I'm going to open up with Notepad. Okay, I'm going to remove this entire content and replace it with a custom code. Okay, so this is a simple HTML code. It has two things. One is the title, which says IIS web server, and a heading which says welcome to this IIS web server, and under that there's a paragraph that says the page is hosted on the web server with the host name NLB 01. So I'm going to click on save and close this. I will go back to IIS Manager, right click on default website, going to manage websites, and then click on restart. I'll go back to Microsoft Edge and I'll reload the page. You can see here it says welcome to this IIS web server, and it says this page is hosted on the web server with the host name NLB 01. I will perform the same steps on NLB 02. So I'll go to NLB 02 and back in Server Manager, click on Tools, click on IIS Manager, expand NLB 02, expand sites, right click on default website and click on explore, right click on iisstart.html page, select open with and select Notepad. I'm going to remove this entire content. All right, the only change which I have done here is the hostname section which says NLB 02. So I'm going to save and close this. I will open up Microsoft Edge and type http localhost. Okay, so you can see it says welcome to the IIS web server. The page is hosted on the web server with the host name NLB 02. All right, the next step is to create an NLB cluster using our NLB nodes, NLB 01 and NLB 02. I'm back in NLB 01 and I've already logged in using an administrator account. And back in Server Manager, I'm going to click on Tools and then click on Network Load Balancing Manager. I'll maximize this. I'll click on the cluster menu and select New. I'll specify the first NLB node, which is NLB 01. Click Connect. When you hit Connect, it will display the two network adapters of NLB 01, cluster traffic and management and internode traffic. As mentioned previously, when using Unicast mode for the NLB cluster, it is recommended to have two network adapters. To load balance the traffic, I'll select the cluster traffic interface for the NLB cluster, and the clients will connect to this network 192.168.10.0/24. By the way, the interface named management and internode with IP address 192.168.50.91/24 will be used for management and internode communication within the cluster. So I'm going to select cluster traffic again and click on Next. On the host parameter screen, you can configure the priority value, which must be unique for each NLB node added to the cluster. The priority value of the first NLB node, NLB 01, will be 1. And for the second node, NLB 02, which will be added later, the priority value will be 2. Next, you can set a dedicated IP address for the NLB cluster nodes. These are the IP address assigned to individual cluster nodes and used to route traffic to specific nodes in the cluster. You have the option to add additional dedicated IP addresses, but for now, I will leave the default settings, which uses the IP address of the network adapter that handles cluster traffic, which is 192.168.10.91. You can also set the initial host state. The default state is started, but you may wish to retain a different state after the computer restarts. For example, you may have other states such as stopped or suspended. In this case, keep the default started state and click Next. On the cluster IP addresses screen, click on Add. Keep the option Add IPv4 address selected and specify the cluster VIP, also called as virtual IP. I will specify the IP address as 192.168.10.90 and the subnet mask is 255.255.255.0. Please ensure that this IP address is not currently being used on the network by pinging it. If you're using IPv6, you could also use those addresses. However, I will use an IPv4 address. So the cluster VIP is the IP address that you present to clients that are connecting to the websites or any services that you are balancing with the network load balancing. So I'm going to click on OK. If required, you can add multiple cluster IP addresses by clicking on Add. We are OK with one cluster IP and I'll click Next. On the cluster parameter screen, you'll need to define the cluster network name. That is the full internet name for this cluster, along with cluster operation mode. For my NLB cluster, I will call it web.tastybiryani.local. This will be the name that our clients use to connect to the cluster and its load balanced services. You also need to create a DNS entry, A record and PTR record for this DNS name. I've already created this DNS entry for both A and PTR record. The IP address again is 192.168.10.90. For this demo, I will keep the option Unicast selected. However, in most production environments, it is recommended to select IGMP Multicast if your networking equipment supports this protocol. I'm going to click on Next. On the port rules screen, configure the port rules for load balancing across the different nodes you're working with. In essence, you will specify the cluster IP address to be used along with the ports, protocols, and affinity rules. So when this default port rule selected, click on Edit. By default, if you have multiple cluster IP addresses defined, they're all selected for clustering purposes because the option All is checked. However, it is recommended that you select the appropriate one for load balancing purposes instead of selecting all. To do this, simply uncheck the option All and you can select the appropriate cluster IP address. In my case, I only have one cluster IP, which is 192.168.10.90. I'll keep that selected. Under port range, by default, it selects all 65,000 TCP or UDP ports for load balancing purposes. You can see the port range starts from 0, all ports up to 65,000. So when setting up an NLB cluster, it is important to configure it properly because not all cluster IP addresses and ports in both protocols need to be load balanced across all machines. This applies to almost every NLB cluster setup. So don't try to balance traffic across all possible ports, but rather customize your approach to target specific important ones. You need to know which ports to use. For this example, I will specify port 80 in both from and to. For the protocols, I will select both. However, you can also choose UDP or both. In the filtering mode section, you'll notice that the multiple host option is already selected. The filtering mode section has two other options, single host or disable this port range. When you use single host, all network traffic for the associated port rule is handled by one host in the cluster based on the handling priority you set. This filtering mode provides port-specific fault tolerance for the handling of network traffic. The option disable this port range filtering mode tells the cluster which ports are not active on the cluster IP address. So any traffic requests received on the cluster IP address that matches a port rule with this filtering mode result in the network packets getting automatically discarded or dropped. So administrators should configure specific port rules and use this filter mode for ports and port ranges that do not need to be load balanced across the cluster nodes. Whereas the multiple host option means that the traffic for the associated port rule can be handled by multiple hosts in the cluster, providing port-specific fault tolerance for handling of network traffic. When the option multiple host is selected, the NLB driver distributes traffic across all cluster nodes. So if one node in the cluster fails, then the traffic for the associated port rule will be automatically distributed to the remaining nodes in the cluster. Under the filtering mode section, there is another thing called Affinity. The available options are none, single, and network. Client Affinity is a feature that allows you to control how requests from the same client IP address are directed to the nodes in an NLB cluster. To explain these options and their significance when we configure Affinity, I will use a graphic and discuss each option in detail. For example, imagine a scenario where a user needs to connect to the service on the NLB cluster that is being configured. Let's assume that the user's machine has an IP address such as 122.57.14.23. When a user connects to the cluster, they are effectively connecting to the service endpoint using the cluster VIP or internet name configured on the NLB cluster. This allows them to access the resources that exist behind the NLB cluster. We know that the main function of network load balancer, NLB, is to direct user traffic or requests to resources or services hosted behind the NLB cluster in a balanced way. What is important to note is that the load balancer is responsible for routing users to machines within the cluster based on the rules you configure. For example, a user may be routed to the NLB 01 on their first visit, NLB 03 on their second visit, and NLB 02 on their third visit when the user is exploring the website. But let's understand how NLB routes the requests from the client to the backend service using the client affinity rules. If you select none for the affinity rule, then there is no client affinity. This means the request from the same client IP address can be directed to any node in the cluster. The none option is a good option to choose if you don't need to maintain a session state to your application. And the none option is simple to configure and can improve performance by distributing requests across all nodes in the cluster. However, the none option does not maintain a session state and can increase latency for clients that are not evenly distributed across the cluster. If you select the single option, all requests from the same client IP address will be directed to the same node in the NLB cluster. This refers to load balancing based on source IP address of the incoming connection. It automatically redirects all requests from the same address to the same cluster member. If you're using network load balancing and you want to direct multiple requests from the same IP address to the same cluster host, then you need to use single affinity. The single option is useful for applications that require a session state to be maintained across multiple requests from the same client. For example, an e-commerce application may need to use the single option. The single option can improve the performance of an application that require a session state to be maintained. This is because application does not have to reinitialize the session state for each request from the same client. When you use the single option, it can limit how many requests your application can handle. This is because the application can only handle as many requests as there are nodes in the cluster. The single option can increase the load on one of the nodes in the cluster. This is because all requests from the same client IP address will be redirected to the same node. If you select network option for Affinity, the client requests will be sent to a particular node based on the subnet of the incoming user. Requests from the same client subnet will be redirected to the same node in the cluster. Let's say for this user who is coming from the IP address 122.57.14.23, setting the affinity policy to network instructs the load balancer to inspect the first 3 octets of the inbound IP address presented by the client to determine which backend server to use. The value of first 3 octets and the resulting hash determine which node in the NLB cluster receives the traffic on this network. The load balancer uses this information to direct the request to an appropriate node. The network option has its pros and cons. It can be useful for applications that require a session state to be maintained across multiple requests from the same client subnet, which can improve the performance. However, if one area of users has a large number of users in the same subnet, you'll find that all the users in that subnet are always going to the same cluster host. Also, the network option is more complex to configure and can reduce scalability if the cluster is not evenly distributed across network subnets. Depending on which option you choose and the usage patterns of incoming users, you may want to configure each individual IP address to be routed to a different server. Alternatively, you may want to group them together in the same subnet so that all users from that subnet go to the same location. One caution regarding these configurations is that you need to be careful about the IP address that the client presents to the NLB cluster when they connect. The specifics of how the client enters the network can vary. Suppose a client is accessing the system through a NAT translation device. Let's say as clients enter the network, their external address such as 122.57.14.23 is translated by the NAT translator to an internal address that makes more sense for internal use. This means the client can present a private internal address such as 192.168.0.57 to the NLB cluster instead of their public address. Depending on your NAT rules, you might have many different clients that appear to come from the same subnet and IP address. Each of these situations could be different depending on how your clients are attaching to the resources behind the network load balancer. If you find yourself in a situation where all the traffic is still routing to the same server all the time, take a look at the affinity configuration that you have set. All right, back in add or edit port rule window, I'm going to select multiple host filtering mode and none for the affinity settings. To set the port rule for the configuration on this first machine and the cluster we are building, I will select OK to proceed. You can add multiple port rules by clicking add again. Let's say you want to use another port such as TCP port 443. I'm going to click on cancel and I'll click finish. And after a second, you'll notice we have completed the configuration change. There you go. We now have a green light indicating that our single server NLB cluster is serving up access to whatever service exists on this machine. To add another host, right click on the cluster, web.tastybiryani.local and select add host to cluster. Type in the hostname of the secondary NLB node, NLB02 and click on connect. Select the interface used for cluster communication, which is cluster traffic, and click on next. It is important to set a priority unique host identifier for the second machine as well as for any subsequent machines. In my case, I'll keep number 2 selected. Next, you can set a dedicated IP address for the NLB cluster nodes. Again, these are the IP addresses assigned to individual cluster nodes used to route traffic to specific nodes in the cluster. And you also have the option to add additional dedicated IP addresses. But for now, I will leave the default setting, which uses the IP address of the network adapter that handles cluster traffic, which is 192.168.10.92. I will leave the default state as started for the initial host state, and I'm going to click on next. On the port rules screen, I will leave the rules which was created before, and I will click on finish. Wait for some time and ensure that the second node NLB02 gets added. All right, you can see it is green as well. To test this configuration, I will log into a client machine named client01, which is connected to the same network as the NLB nodes. I'm going to log in as an administrator. I will open up Microsoft Edge and type in http web.tastybiryani.local. Press enter. Okay, you can see it's loading the page from NLB01. I'll hit refresh again, and it is still loading from NLB01. Okay, now I'm going to shut down NLB01. Okay, I'm going to go back to the client 01 and I'll refresh the page. And now you can see it is loading from NLB02. So this shows our NLB cluster is working as expected. Let me power on NLB01. The NLB Manager contains several management tasks that you should be aware of and prepared to perform for day-to-day administrative activities. So I'm back in NLB01 and I'm going to type the administrative credential. And in Server Manager, click on Tools and click on NLB Manager. So you can see NLB01 is currently stopped. And when you right-click on a NLB node and navigate into Control Host, you'll see options such as Start, Stop, Drain Stop, Suspend, and Resume. The Start option initiates the NLB service on the selected node, allowing it to receive user requests if it was previously stopped. I've clicked on Start and you can see the status, it's saying pending. Okay, you can see it is enabled and it is green right now. And if I right click on the node again and go into Control Host and select Stop, it will halt the NLB service on the selected node and preventing it from receiving user requests. You can see it is red right now, which means it is stopped. Let me start again. Now when I right click again and go into Control Host, you can see the option Suspend, which will temporarily suspend the NLB service on the selected node, causing it to stop receiving user requests. And if I right click again, go into Control Host and click on Resume, it will reactivate the NLB service on the selected node, allowing it to receive user requests if it was previously suspended. If I right click again, there is a special option, Drain Stop, for stopping the NLB service on this host. The service does not stop immediately. It continues processing all inbound connections until they have terminated. This provides your users with an opportunity to gradually shift away from the current server and onto other servers before you completely shut off their connections. If you have a stateful data on this server, this approach is ideal for safeguarding those connections until users have completed their work with your services. Lastly, let's talk about the upgrade process for your NLB cluster. If you have a previous version of NLB and are upgrading to a new version of Windows Server, the only thing you need to know is that a rolling upgrade is a typical process to update your cluster nodes to a new OS version. Here are the step-by-step tasks you must perform in the following order to upgrade the operating system on an NLB node. First, you will drain stop the node. So this is the process which starts with a drain stop, so draining off the connections. Next, you'll power off the node, which will power off the NLB node. And the third step is you will upgrade the operating system on the NLB node. The fourth step, you will power on the upgraded NLB node. And the final step is that you'll rejoin the upgraded NLB node to the cluster. So this process allows you to perform the rolling upgrade across different NLB nodes one at a time until you have completed the task on all the nodes in this cluster. In fact, the upgrade process is fairly easy, and considering that the NLB is more or less fundamentally the same thing as the NLB you're working with in previous versions of the operating system. All right, that's it. I hope you like this course on how to use Windows Server network load balancing. I hope you like this video. For more videos like these, please subscribe to my channel.